We'll edit this part out.
Fucking cough now.
Everyone, welcome back to the DrainGear podcast. We're excited today to have a special guest with us. I'm going to introduce him in just a minute, but we've got a little bit of a different format. We're going to try something new today where we're patching somebody into the podcast from across the pond. And so we're pretty excited about that. I'm flying solo today, except for my friend here on Zoom with me. So we're going to do our best to try and put this together in a format that you'll be able to really enjoy. With that said, we're going to launch into this. I've got with me Rich Ingham from Ferret Technologies in the UK. And Rich is somebody that I stumbled across kind of on accident, but fortunately for me, it turned out to be a really good interaction and meeting. And we're very excited to have Rich with us today. And he is a very knowledgeable person as it pertains to leak location in the water industry in the UK. And they take it pretty serious there in the UK. And so he's got a lot of really good, deep-rooted history and family background in the water business. So, Rich, welcome to the DrainGear podcast. Happy to have you here and really excited to talk with you today about Ferret Technologies. So tell us a little bit about yourself.
Hi, Jake. Well, yeah, thank you for having me. Excited to be here too. So, yeah, it's been quite a journey. I prefer not to say how many years because it makes me feel old, but it's been a long time. And I've been really looking for leaks for probably getting on for 30 years now. Started back, was really pretty much my first job in a leak detection company. We spent a lot of time looking for leaks. And one of the big problems we found, one of the big challenges, was finding leaks on plastic pipes. A lot of the technology that was available at the time was designed around finding leaks on metal pipes, essentially acoustic technology, listening for the noise a leak makes. And as more and more plastic was going in and being buried underground, and then this started to leak, and we kept coming up against this challenge, which was that these leaks make very little noise. So myself, my father, and my grandfather, who have all been in and worked in the water industry, came up with an idea. What is really quite a nice, simple idea, and that was that if you installed essentially a balloon inside the pipe and you inflated it, you could then use the water pressure in the pipe to push it along. When it passed the leak, the idea was that what would happen is the water passing out through the leak would drop the pushing pressure in the pipe, and the balloon would stop on the leak. Seemed like a good idea on paper, so that was really the start of the journey. Again, over 20 years ago now, we started with that concept, and started prototyping, and probably I would say 2 or 3 years later, we had our first Ferret Leak Locator.
Wow. That's great. So 3 generations of water detectives, let's say, really formulating a plan and coming up with a really unique product. And you talked a little bit about that balloon. I've got one of those here attached to the Ferret. And so I would imagine that this was not your original design. This has probably been refined over time. It's just a really well-made product, and it's unbelievable what this thing's capable of. But this is what you're talking about, the balloon, and then just behind this you do have a locating sign. Do you want to talk a little bit about how the Ferret, once it reaches the leak, how you're able to locate it in a few different fashions?
Yeah, so you're right, Jake. What you had there was the balloon, and the yellow part of that is the inflatable part. And then, as you say, it's all very well finding the leak underground, or the Ferret finding the leak for you. But once you've done that, you've then got to work out whereabouts underground that is. So what we built into the system was a trace wire. And then in addition to that, a little radio transmitter, which is all waterproof and potted within that system there, all enclosed. So that essentially once that Ferret balloon has located the leak, you're able to use a combination of distance marks on that tube that's inflating the balloon, the trace wire inside it, and that radio transmitter that's located just behind that ferret balloon to essentially get a crosshair of exactly where that leak is. And in plastic, when you use the sonde, you can even locate the depth of that leak.
So really a few different methods for pinpointing where the head is at.
Yes.
Nice.
I should say that whilst we did originally develop this for a plastic pipe, the system works equally well on any really relatively smooth bore material. So it will work just as well in copper pipe, in lead pipe. In those scenarios, the metal actually shields the signal from the radio transmitter. So once you've located a leak in a metal pipe, you will then use distance and line to again pinpoint extremely accurately where that leak is.
Sure. And to do that, to accomplish that with the Ferret, you'll have to have some additional equipment, which most plumbing companies or drain service companies would have, and that's just some simple locating equipment. There's a variety of different manufacturers. I know we use C-Scope at your recommendation, and we've been quite happy with their products. We sell those here, and they work really well with the Ferret. But if you have, say, a rigid locator or a general locator or something comparable to that, that will pick up multi-signals, you should be pretty good. And how do they go about doing that, Rich? They just attach that transmitter right to the Ferret.
That's correct. You need the transmitter and the locating tool, the CAT as it's referred to, and you are essentially the wire that is connected from the system to the Ferret balloon. You're essentially tracing that metal wire. So it's exactly the same process as if you were tracing a metal pipe.
Sure.
But the beauty is we've introduced a metal line inside the plastic pipe.
Right.
So yeah, you're doing exactly the same. It's exactly the same process as tracing a metal pipe.
Right. So you've been here to the United States a couple of times. You've spent some time with us here. And one of the little projects that we went on locally here, we had gone out on site. I'm sure you remember because it was a rainy, kind of blustery day. You were covered in mud by the end of it. That's when I realized this guy is this guy's the real deal. You were in the ditch, you were in the mud, just getting after it, and I was just so impressed with your the way that you worked in the field. It was very impressive. But a couple of jobs that we had done locally were pretty interesting. And the one that sticks with me is that a local company had been out and they had tried all the traditional means of locating this particular leak, which was a fairly decent leak. You would think that it would be fairly easy to hear potentially using listening techniques, but some of the obstacles were a lot of landscape. There were a lot of leaves on the ground. It was raining. So you have all these crazy elements happening in that situation, and it made it very difficult. When we showed up, if you remember, Rich, the yard had already kind of looked like Swiss cheese. There were paint marks everywhere. There were there were little holes where he thought maybe he had been over the top of it, and as it turns out, he just never really pinpointed it. And so we accessed the system and put the Ferret in and sent it down, and very quickly we're able to kind of narrow that down. And I think we got it, what was it, within 3 inches we had found that leak. Yeah. And so we dug down and found it. So.
And that's the key thing, I think, Jake. Putting something inside a pipe, one of the drawbacks is you've got to get it in the pipe.
Right.
And we accept that, if you can use the acoustics, you can walk down a sidewalk. If you can hear it straight away, then that's great. But there are very, very many leaks where that's not the case, and there are all sorts of things from the depth that pipe's buried at may vary.
Right.
On copper, you tend to find as well that the noise transmits extremely well, and in actual fact, you often get a false positive, as we call it, where the pipe's actually just running at a shallower depth for a period, and actually that's where you're getting the loudest noise. The thing with Ferret is once you've got it in that pipe, you are going to find the leak, and the great thing with the Ferret is it's the accuracy. You are going to find that pipe, that leak on that pipe within a couple of inches. A reasonably experienced operator will do that every time. And I think the other thing with the Ferret is it's also testing the pipe as it goes along. So whilst this may sound a bit silly at first, the ferret also tells you where the leak isn't, which no other system will do. So you're very quickly able to eliminate large sections of the pipe because you can essentially stop and inflate that balloon anywhere you like, and the system has a built-in flow meter, which is very sensitive, and a pressure gauge, which will tell you whether that section of pipe you've travelled along is actually good.
Sure.
So that's another thing that you're always moving forward when you're surveying with a ferret. You're always narrowing down the location and moving the job forward. You're not in a scenario where, for instance, if you use acoustics, you may get to a situation where you can't hear it. You've got some airborne noise interference. You've got pumps running, etc., that are all, affecting your outcome. With a ferret, once you've got it in there, you are going to find that leak, and you are going to find it extremely accurately.
Right. So, in terms of navigating through a line, you can find tees. Are you able to pass through fittings? Can you talk a little bit about the ability of the heads to pass through fittings? And we'll also address, a lot of people ask, can it go through 90s? And so we'll talk about that in a moment. But the big thing is, passing through tees or passing through, say, couplings or connections. What can you tell us about that?
Yeah, so certainly fittings. There's whilst there probably shouldn't be quite as many as they are, we come across fittings in the line all the time.
Sure.
And I know from my experience with you over there, Jake, you use the Sharkbite fittings, and some of these fittings have what we would call a ferrule or an insert. So there's a liner within the pipe to keep the pipe in a nice circular shape when the fitting's clamped around it.
Right.
And they obviously generate they create a small restriction in the pipe. But more importantly, what you've then got is this little shoulder edge within the pipe as you travel down it. And there are tracing systems that you manually push down the pipe. And what you'll tend to find with any of those systems, generally the tracing systems, is when you meet one of those shoulders within the pipe, or those edges, you tend to find you can't get past it. The system will jam on that, catch that edge. We've designed the ferret balloon. Well, there's two things with a ferret balloon. One is you're inflating it to its operating size, so you can always deflate it to fit through a restriction. And we've got a nice rounded nose cone on the front of that balloon, which is sitting centrally off the edge of the pipe. Right. So when you do meet one of these restrictions, the ferret will go in there and it will stop because it's come to a restriction in the pipe. And again, often our systems are used to actually locate where fittings are in pipes, because again, in many systems and new plastic pipes, often it's the leak that's been potentially badly installed in the first place, which is actually the leak point.
Sure.
So yeah, the ferret, when you get to a leak, you can let that balloon down, you can pass through that fitting, you can then re-inflate on the other side, and then you can test that fitting. And again, any fittings that aren't leaking, you can locate them, map their position, you can test them, and then on you go to the next fitting. If it's a T, and as long as if we're talking about a T, and we're not talking about a T where we're coming up, if you like, the bottom of the T to the hammerhead.
Sure.
We're not in a position yet where we could turn left or right, but you tend to get the scenario you tend to get is where we pass through the T and we've got a side branch going off to one side.
Right.
You can use the ferret to actually map where that T is, because what you would have is that T would be feeding maybe a second tap in the yard. You can generate a flow at that point, and you can use that flow then to map out where that T fitting is.
Sure.
The other beauty of the ferret, and we've had a number of scenarios where we've had side branches that weren't known about. The classic one for us in the UK is where a developer develops a site. They have a supply going off to the cement mixer or the porter cabin on the site where the site office is. And at the end of the job, rather than remove that T from the original line, what tends to happen, unfortunately, is that pipe is just capped off at the end and buried. And then what you have is a scenario where if ever there's a problem on that line's actually being forgotten about or unknown. And what the ferret will do is it will test the entire side branch for you as you go along, even if you know it's there or even when you don't know it's there.
Right.
What tends to happen when you don't know it's there is you'll dig down, there'll be a dry hole, but what you'll find is a T instead of a leak. And at that point, you can decide whether you want to do away with the T and just piece it through, or whether you actually want to then send the ferret down the side branch. But as I say, what the ferret will do, which again, as far as I'm aware, there's no other system that can do this, is it can test all of those side branches for you as it goes, regardless of how long they are.
Yeah, one of the scenarios that we talk about when we do training with contractors here is that, a good example here in the U.S. would be if you're maybe on a farm property or some sort of a ranch or, a big commercial property even, you can get into that main line and you can locate those T's that may go off to a horse barn or a second building somewhere on the property. And the beauty is once you pass that T on the downstream side, you can pressurize the ferret head and pressurize the system, and you'll know that whole entire branch line is either got the leak in it or it's good. And you can go about your survey. And so we really like that feature. I mean, being able to find irrigation connections on a golf course, for example, where you certainly don't want to turn a golf course into Swiss cheese. I do when I golf, but you don't want to do that on purpose.
So do I.
So it's just a really unique tool for doing an entire system where you can segmentally pressure test internally inside of a water line. And we can go down to some pretty small sizes. Do you want to talk about the range? I've got 3 ferret heads here in front of me right now in a range of sizes. But do you want to talk just a little bit about what size pipes we can access?
Yeah, so our smallest balloon currently has a cross section. Now, I'm afraid I'm going to use the UK dimensions.
No worries,
so
I'll translate.
Yeah, we're talking 8 millimeters. So what are we talking about?
So we would be
a third of an inch.
Yeah, we would say probably a third of an inch. Really, 3/8 would be a pretty small line as well. Yeah.
Yeah, we developed that for the 3/8. We've got a lot of lead, and again, I know you guys have got lead in some of the older cities.
Mm-hmm.
So we're getting down the small bore lead with that. We're doing our 15 mil coppers and our 3/8 inch pipes. Again, when we're looking at the right size ferret head, we're talking about the internal bore of the pipe, which depending on the wall thickness of the pipe can vary. But the key thing when you're using a ferret and working out which size ferret to use, it's the internal bore of that pipe,
Sure.
and again allowing for any the jointing technique in that pipe. So copper tends to be solvent welded from externally. It's your plastics where you tend to get your fittings that may have a liner or a ferrule within them that cause a small restriction. So again, you need to allow for that. So yeah, the small end of the scale is down there. We call it the size 0 because when we started out with size 1, we thought that we couldn't possibly go any smaller. And yeah, in time, we redeveloped things and got down to an even smaller size than that. So that was the size 0, which is 8 millimeters.
Yeah. And what's good about that is... Oh, go ahead.
I was going to say, the other end of the scale, we're looking at 1.5 inches, 1.75 inches sort of pipe. Again, depends on the class of the pipe and the wall thickness. That's where we currently are, but I would say we're very close to even bigger sizes. Essentially, we're working on 2 inch and above.
That's good. One thing I was going to say is that in a line where you may have some little kinks or crushes, where maybe a rock has set on it, or during installation when they were rolling, say, copper out, for example, you might get a little pinched point in that pipe. And can you talk a little bit about how you can downsize the head to maybe kind of navigate through that, but still be able to, expand it past that point?
Yeah, I mean, essentially that ferret head it's a nice neat cylinder before you inflate it, and when you inflate it, it will give you a fairly uniform ball shape. But essentially, that balloon will create any shape, and it'll do that dynamically as it travels down the pipe. So if you do get to a crush, sometimes if it's a really bad crush, the ferret would stop, and you would need to deflate it, and then it will pop through, and away you go. And we do even have scenarios where, let's say, for example, you're working with a size 2 balloon and you get to a restriction you just cannot get through, or a crush you cannot get through. You can always then, an experienced user would know that they can retract the ferret, put a smaller size balloon on, go back to that same point, and then potentially get through with a
Right.
smaller balloon, and know that then you've just got to work a little bit more gently because you are working at the end of the tolerance of that size of balloon.
Right. Yeah, and that makes it really user friendly from the standpoint of access. So, um, speaking of access and what you need to be able to do a survey, there's some other kind of parts and pieces and hoses and connectors that come along with the system. You'll have to adapt depending on your location and what type of pipe you're working with. You may have to adapt with different types of fittings to different types of materials. All very simple. We mostly just use either some type of a compression fitting, just very basic, with a male thread on it or whatever, to tie back into the ferret. But we're not using any electric. We're not using any air pressure. There's none of that. This is simply you're using the water in the service line to make the magic happen, essentially. So, that's a really nice from the standpoint of being a good benefit. You don't have to have any additional equipment, to be able to do a survey. It's just access is key.
Sure. And in fact, Jay, were we talking about the journey we've been on? We did used to use electronics within our system with LCDs and electronic gauges, and we got to a point where we thought, hey, hang on a minute. The beauty of this system is it's driven by the pressure in the pipe. We don't want to put our customers through a scenario of having to charge this thing up, having to, anything with electronics in it is generally more expensive than an analog gauge.
Right.
So we actually thought the best way to take this forward is actually to take it back, if you like, to the real simple hydraulic principle it's built around, where we're using the water pressure, as you say, in the pipe, and use analog gauges, use basically a very sensitive turbine flow meter. So we're getting all the information we need and being able to do the job with the water pressure in the pipe essentially being our power source.
Yeah. Yeah. And that makes it really easy if you're taking this thing around in your service truck or your service van. It's fairly compact. The design has changed a bit, but it stores very easy. It's very durable, quite rugged. It's easy to fix. We do have all the parts in stock here if we need to make a repair to the ferret. I've heard horror stories about guys doing a locate and then cutting into the pipe and cutting the umbilical in half. In our world, Rich, in the sewer side, a lot of guys will get that with sewer cameras, right? So you go do a locate and then you get your chop saw out and you cut right through the pipe, and then only to realize you've cut the head off of your very expensive camera. So a similar concept. You got to use a little caution when you're accessing the pipe, but from a usability and portability standpoint, we have a little Milwaukee pack out that we keep several different ferret heads and little hoses and parts and pieces and some compression fittings and glue and little parts for patching things up, and then we have our ferret. And so it's really nice, just a small toolbox. It's got everything we would need to do things with, and then the ferret itself. So it's very compact, easy, and portable. And it's nice that it doesn't have to be hooked up to electric or air. So that's one thing we really like about it. So tell us a little bit about where you started with the design to where we are today. Because when we first met, the whole reason that I even recognized this tool as a useful tool was that I thought the original version that I saw looked like a little, what we call, Rich, an inversion drum. And that's what we use to send liner down pipes. And so when I first saw it, I thought, somebody created a small little pressure chamber for inverting really small liners, or what is this thing? And as I delved into your website, I realized very quickly what a unique tool this was. And I got really excited because the plumber in me said, wow, this is a really unique, method of leak location. I got to talk to whoever these guys are. And that's when I called you and away we went. But tell us a little bit about that journey of kind of the probably early on archaic versions of what you started with all the way through to this really, really nicely designed product.
Yeah. Okay. Well, I think the first thing is before we designed anything, we spent it was me personally and a couple of other guys in the company. We spent 4 weeks on site with a water company in the UK who are very proactive at fixing customer side leaks. And we went out with our guys, said we'd help them with the shovel, and that gave us an opportunity to look at what they're up against. Really, we've had a lot of experience of leak detection and location, but it was good experience to get out there and see really the environment that these guys are working in, day out. And you're talking potentially deep, muddy holes.
Oh, yes.
A pile of mud, a wet mud. It's raining, and generally you're digging a hole that's got a water supply into the bottom of it, the leak. So it gets wetter and wetter and messier as you get closer to a result. So we knew whatever we built had to be robust, and we know that, plumbers aren't stupid. They want good kits. They want, and many of them will, they want something that's reliable, that's not going to let them down on site. It's a really important thing. So our first unit was, shall we say, over-engineered to some degree. And as I mentioned earlier, we'd built in electronics. And I think that was the first thing we learned, was that, one, we didn't want to, as we progressed, we wanted to remove the electronic element, because it sort of went against the whole principle of the machine, the simple hydraulic process that the whole business is built around. And the other thing was that most of the components we'd used were off the shelf. We're talking about a food product. We're talking about drinking water. We'd used lots of things off the shelf that were from, say, pumps, things that were spinning at very, very high speeds. Other fittings that were, we were talking maybe 300 bar or serious PSI. And we realized that a lot of these fittings were over-engineered for what they needed. And we could see a way to bring the price of the unit down over time without compromising on the quality and the ruggedness and robustness of the unit. And so we've been on a bit of a journey. We did the unit you saw, Jake, that you mentioned when you first looked on our website. We'd actually moved into using plastics. And in fact, we had a change forced upon us there, really, where the plastic material we were using, a food-grade substance that we wanted to mould, was actually the supply of which started getting shorter and shorter and shorter. And again, it sort of led to an opportunity to say, hey, we've had this one on the market for another 2 or 3 years. Let's look at this now. And the other thing was allowing guys to fix these. As we started to expand and export all around the world, there are some regions where we had distributors and support, like a good sales, a big market, but we've sold these to much smaller countries and regions, if you like, where there isn't a big enough market to really have a distributor fully geared up with all of the spares and the tools.
Sure.
So again, we wanted something that was much simpler to maintain and fix, if you like. And another thing I think that's led to a lot of changes is initially we were putting things where they needed to be, maybe for a molding process, because our hands were tied by certain things. And again, that's led to the development and the involvement of the product, where things are laid out. We've now got nice graphics on there, which give the user a sense of where things go and how things work. To start with, it is one of those principles, I think, where people almost, it's too good to be true. They don't quite believe this thing's going to do what we say it will. And I think it's one of those. Again, it turns up and there's levers and there's knobs and there's gauges everywhere, and they're thinking, wow, this looks tricky. But I think once you actually use it for a bit and a couple of times and see what it can do, and then if you like grasp the principle, you realize, wow, what a really simple process this is.
Yeah, it is.
And I think that's the journey we've been on, is actually, as I say, taking out the electronics. Hang on a minute, why have we got electronics in this thing when it's powered by water?
Right.
Why have we put a battery in? Well, the things you kind of learn these things as you go along, and you realize, hang on, and you refine what you're about. I guess it's that thing when you start a company and when you move along. And again, what you don't have on day one is any customers.
Right.
And once you have some customers, you can really start to talk to them and understand what they want. And take that on board as you go along.
Yeah, it really is a beautiful piece. It's almost like artwork, to be honest. You guys have done a wonderful job. And, I was so impressed with the little blue plastic the first model that I was accustomed to, and I just thought it was just such a neat piece. And we've got one still here. I put it in the showroom, and it kind of sits there. And I love to look at that and then look down and see the new, revised version. And it's just, for me, I'm kind of proud of it because I was kind of part of that a little bit, just being, kind of the new guy in the United States, and just being a part of that transition. I would say that, COVID was a little bit of a hurdle, but at the same time, probably good in some aspect to give you some time to really get that perfected. And it's a beautiful new version that you've got. And it's mapped out well on the top. It really shows, how things are laid out on there. Very good understanding of what you're doing once you get used to it. Our young guy, Taylor, Taylor here, he does a lot of our ferret training, and he is just, he's really got this thing down, and he's got it dialed in and really knows how to work it. And he's really good at training. So anybody that's interested in the ferret, just know that we've got a really good trainer here that can help accommodate on the training side. He's worked very closely, personally, side by side with Rich, and we've spent a lot of time on the phone with you as well, just making sure that we fully understand things. But thanks for that explanation on that bit of transition that the ferret has made over the years. The other thing that I would say is that there's a really good user manual. You have a lot of really good videos and content available, but the user manual is really it's nice. It's got pictures, and it's very foolproof. It's easy to understand from the standpoint of knowing what you need to do with it. The other thing too is that the ferret does come with some accessories that could be available for different access points and different methods of getting the ferret into the pipe. Can you talk a little bit about access and some of the methods that you use? I know they don't necessarily translate across all regions and places in the world, but for the most part, there's adapters and different things that you can utilize. So can you talk just a little bit about those accessories?
Yeah, so we appreciate that any what we put in the generic term, if you like, insertion technology. You've got to get this thing in the pipe,
right?
And that's where, again, we've worked with a number of our customers over the years, some of whom are more than happy to dig a hole in the pavement. Others are we don't want to do that. We need an opening notice from our county councils. It all gets a bit long-winded. Can we put this thing in at the other end of the pipe and come backwards? And so over the years, we've developed different tools. Again, other manufacturing processes have been developed over time. When we started out, there was no such thing as a 3D printer. We're now in a position where we can sit down with a customer and say, well, how do you want to do this? What fits with your operating procedures? Have you got plumbers who are happy to go inside, for instance, and take out a valve inside the house? How, for instance, you've got your meter sets, your meter setters. So again, we can look at your meter setter. We can possibly access those where we've looked at, you've got a non-return valve, which is a serviceable item just downstream of the meter on the meter setter. We, for instance, would develop a fitting that's screwed into that, allowed you to take your water down to the house, and then you could essentially run the ferret backwards up the pipe to find the leak without having to dig a hole.
Right.
So we're very focused on the no-dig access, if you like. Anything we can do, we know that really then one of the drawbacks of insertion technology is getting it into the pipe. And if you've got to dig a hole to do that, we accept that's time-consuming. We know that we've got hundreds of customers all over the world who accept that's something they're going to have to do because of the benefits that then the system and the accuracy they get from doing that. But as I say, where we can, we've worked with different customers. We've got a customer in Belgium who we work with. We've got customers in New Zealand who we're dealing with, and obviously you get yourself, Jake, where we've looked at the systems over there. What you tend to find is that they're done that regionally. Whilst you've got huge differences to the way things are done in the US there in terms of state by state and even regions within the states, what you will find is that generally plumbing companies are working in an area and there'll be lots of similarities as to the way the plumbing infrastructure is laid out, from the type of meter setter that generally gets used to the way whether you've got your crawl spaces, whether you've got your basement spaces where you've got this pipe coming in through the basement wall with a valve on it there that's a very simple thing to remove, and then we get access at the other end, and we use a hose that basically we run a water supply up the driveway, and then we can send the ferret backwards.
Right.
We've even got customers who want to pump systems. We're looking at people who are working on pool systems and this kind of thing, and they're using the water supply, water supply A to look at system B. So you can take pressurized water from any system. You can take it from a tank even, and with a little pump set. So yeah, there are lots of things you can do to accessorize the ferret and the process, if you like, to make it simpler and quicker.
That's awesome. So good versatility as well. It's another thing that we really like about this system. So I guess one of the last things that I would like to discuss, at least from my side, is when we talk about this, this isn't, if you're looking to get into leak detection, this wouldn't be the only tool that you would need. You would probably want to have some listening equipment in addition to this. What other items or accessories would be necessary? We did talk about locator and transmitter, which you can touch on if you'd like. But what other useful things would be good if you said to a plumber that is looking to get into leak detection, leak location, what's a good kind of package to start out with, including the ferret, of course?
Yeah, well, I would say you'd need some kind of acoustic technology for sure. And I think that probably the first thing I should say is there's really, certainly in my experience, there's no one tool that is going to say, that is going to find everything.
Right.
You have got all sorts of scenarios out there, all sorts of situations, and all sorts of external factors that make this a real challenge.
Of course.
I mean, finding leaks on buried infrastructure until someone comes up with X-ray vision that really works.
Right. Superman.
It's going to be a real challenge.
Yeah.
And to do it efficiently and do it well, we are talking about, in lots of cases, we may even be digging through floorways to find slab leaks, under slab leaks. We're digging through expensive driveways and then we've got to think about our reinstatement costs. So yeah, I'd say you would want some form of acoustic technology. The very basic is a listening stick,
right.
Just literally like a stethoscope, or you can get more high end stuff. But you're going to want that sort of equipment. There are other systems, the gas injection system. So that's another option. But they're essentially the three key tools you've got for
right.
leak detecting.
Yeah.
That sort of equipment. The other thing, if you have got the ferret in your toolbox, then you're going to need a measuring wheel to go with that, because again, we can find leaks so accurately. And I think one thing we haven't touched on, Jake, with these other pieces of equipment is the size of leak you can find with a ferret. We literally can find a drip.
That's right.
So that's a key point. And we're finding leaks that make no noise. So this is where, with a big leak, you can use your acoustics, and there's nothing more efficient than if you know where the line of the pipe is, that service line is roughly, and you can do a quick acoustic survey above ground with no interference. That's always going to be your first port of call.
Sure.
If you start to get into a situation where you don't really know where the pipes are and you're looking for what is a relatively small leak that may not be really making any detectable noise at all, that's when you're getting into where the ferret's really going to come into its own.
Yeah. Yeah. That's a good point. Yeah. When we do our demonstrations here, you've taught us well and I think we've kind of learned a little bit together, at least on the ways of how to put pipes together here in the U.S. Lots of trips to Home Depot. So yeah. We've been able to cobble together a few little scenarios, but one of the things that I really like to do is when we hide that little tiny drip underneath of something or away from view, where we give a contractor that comes here for training the opportunity to find that little drip. And when they find that little drip, it's like that aha moment. It's like, whoa, wow, I can't even believe we found that, and that's when we start seeing the high fives and the, pats on the back. And it's exciting because you're able to solve these problems that you otherwise wouldn't be able to do easily or at all. And so that's what's really nice about the ferret. Along those lines, just real quick, I'll touch on, remember remember the demo we did where we were doing a demonstration on a live system, and they had set up a training scenario at this particular contractor location, and they had set up manifolds. This was purposely cut into their live system that serves their building, and they had valved it off, and they had some lines that purposely had leaks that they could actually turn on and off for training purposes. Well, when we got into the main line, if you remember, Rich, we sent the Ferret through, and all the valves were off on the training manifold, but we still had a leak, and so we, it was a local plumbing company. We found a leak in their service line, and it wasn't supposed to be there. So I thought that was really funny, and I think it was at that point that the owner of that plumbing company said, "This is really unique. We never would have known that. We didn't realize we had a leak." They ended up digging that up. It was underneath of one of their buildings. They had to dig it up outside of the apron and kind of dig under just a little bit and tunnel back to where the leak was. But I thought that was really interesting that we found a leak that nobody even knew was there in that
Yeah.
process of trying to do a demonstration. So that contractor bought two ferrets immediately. So so that was a good
Right.
testament to how good the ferret did. So that was really exciting to see. But what a great tool! You've done a great job. The team there has done really well, and I'm looking forward to being able to get out and demonstrate this now that the the pandemic is starting to kind of clear up a little bit, and we're getting to be face to face with people more and more. We will have this product at the upcoming Wet Show in February, so we're really excited about that. I'm not exactly sure in what capacity that we're going to be presenting the product there, but it definitely will be there on display where people can actually get their hands on it and take a look at it. So um, hopefully you can join us as well. If everything works out, it would be great to have you over. If not, we'll do our absolute best to represent the product for you. But we're really excited to get the ferret out into the world in the coming year and really do some good demonstrations. So we sure appreciate
Right.
you being with us, Rich. It's great to see you, and I can't wait to see you in person again. I know we did a bit of traveling there for a while before COVID, so I look forward to getting to hang with you again. I really enjoyed that. So,
Right.
all
Yeah,
right,
I did too, Jake. And yeah, love to. I'd love to be there. So let me in. I'll be there.
yeah. And if anybody wants any additional information, of course, you can go to the Ferret website, the home site there in the UK. We've also got a Ferret-Technology USA website available, or you can check it out on DrainGear.com, of course, where you can purchase online. And if you have any questions or would like more information, we'd be happy to send you additional information or arrange a demonstration here in our facility or maybe at your location. So, again, Rich, thank you so much for joining us today on the Drain Gear podcast, and look forward to talking with you and seeing you soon.
My pleasure, Jake.
All
Yeah,
right.
me too. Look forward to seeing you soon. Take care.
Cheers.
Cheers.